Today I will be teaching Laplace transforms and its applications to electrical circuits. So this is actually model number 4, and these topics what I will be doing today and tomorrow will be there for your final test. Laplace transform of a function Laplace transform of a function f of t is defined as follows. Laplace transform of f of t is equal to f of s. Please note that all time domain functions are denoted by small letters or lowercase letters. F of t, small f is written. F of s means uppercase letter or capital F is written. Laplace transform of f of t is equal to f of s. By definition, if you put a triangle and equal to, it means by definition is integration from 0 to infinity e to the power minus st f of t dt. This is how Laplace transform function f of t is defined. So now I give a table of important functions whose Laplace transforms are required, right? Table below gives Laplace transform of some of the important functions. Just memorize this table. This is f of t greater than equal to 0, and this is f of s. First one is Laplace transform of 1. Laplace transform 1 is what? 1 by s. Laplace transform of t is what? 1 by s square. Laplace transform of t to the power n is what? N factorial divided by s to the power n plus 1. Laplace transform of e power minus at is 1 by s plus a. If it is e to the power plus at, it is 1 over s minus a. Laplace transform of sin at. Laplace of sin at is what? A divided by s square plus a square. Laplace transform of cos at is s divided by s square plus a square. Laplace transform of e power minus at into sin bt. Sin bt is what? Is nothing but b divided by s plus a whole square plus b square. Laplace transform of e power minus at into cos bt. Cos bt is equal to s plus a divided by s plus a whole square plus b square. This table you have to memorize, and I am very sure all these things you have studied in mathematics in your first year of engineering. I will not waste much time on how to get these expressions. You have to memorize them. Next, I will teach you some of the important properties of Laplace transforms. Important properties. No need to do the proof of these properties. First property, linearity. Laplace transform of a1 into f1 of t plus a2 into f2 of t is equal to a1 into f1 of s plus A2 into F2 of S. This is called linearity property. Second property, time shift property. Time shift property. Time shift property. If Laplace transform of f of t is equal to f of s, then Laplace transform of f of t minus t naught is equal to e to the power minus t naught into s into f of s. What it means is, in f of t, if you replace t by t minus t naught, f of s gets multiplied by e to the power minus t naught into s. I repeat, in time domain, if you replace t by t minus t naught, in s domain, f of s gets multiplied by e to the power minus t naught into s. This property is called time shift property. Next property, frequency shift property. Frequency shift property. If Laplace transform of f of t is equal to f of s, then e to the power you can say e to the power at into f of t is equal, then Laplace transform of e to the power at into f of t, Laplace transform of e to the power at into f of t is equal to f of s minus a. What I mean by this property is, if you multiply f of t by e to the power at, s gets replaced in f of s by s minus a. Why it is called frequency shift property? If you see S plane, it has got real axis sigma, imaginary axis j omega. Any point in the S plane is given by s is equal to sigma plus j omega. That means s is the function of omega. Therefore, any function of s is called frequency domain function. What I mean is, very important property, if Laplace transform of f of t is equal to f of s, then Laplace transform of e to the power a into f of t is equal to f of s minus a. Last property is time differentiation property. Time differentiation property. Time differentiation property. If Laplace transform of f of t is equal to f of s, then Laplace transform of df of t by dt is equal to s into f of s minus f of 0. This is called time differentiation property. These four properties are sufficient for us to study this module. Now we go to important electrical signals. Important electrical signals and their Laplace transforms. First function is called impulse function. Impulse function. How do you define an impulse function? An impulse function is defined in this manner. Delta of t is equal to 0 when t not equal to 0, and integration from minus infinity to plus infinity, delta of t dt is equal to 1. This is how an impulse function is defined. There are two expressions to define the impulse function. delta of t is equal to 0 when t not equal to 0, and integration from minus infinity to plus infinity, delta of t dt is equal to 1. This is the definition of an impulse function. Schematically, it is represented in this manner. Let us say x-axis represents time, y-axis represents electrical signal. So, y-axis I will write delta of t. Delta of t occurs only at t equal to 0, elsewhere it is 0. Please look at this expression, delta of t 0 when t not equal to 0. That means where does it occur? It occurs at t is equal to 0. By the side of the arrow I have written a number 1. It is not the amplitude of this signal, it is the area under this signal. Right? The number, please report, the number by the side of the arrow, the number by the side of the arrow does not denote the amplitude. Does not denote the amplitude. Rather, it defines the area. Defines the area under the impulse function. Area under the impulse function known as strength of the impulse function. Known as strength of the impulse function. Known as the strength of the impulse function. Known as the strength of the impulse function. Normally people get confused about this number. They think it is the amplitude of the function. No. This number denotes the area under the impulse function defined by this equation. The very important property of an impulse function called shifting property. Right? A very important property of an impulse function is called shifting property. It is not shifting, it is shifting property. What do you mean by a shifter? In English we have got a word called shifter. Shifter means the strainer. In Kannada they call mandri. That is called shifter. The property is called shifting property. Please don't think it is shifting property. More of this property is studied in the next semester in a course called Signals and Systems. A very important property of an impulse function is called shifting property. What? And is defined below. What is this property? Integration from minus infinity to plus infinity, f of t into delta of t minus t naught dt is equal to f of t evaluated at t is equal to t naught is equal to f of t naught. So this property is used for finding or for evaluating an integral when impulse function is present inside the integral. Where this impulse function is present, it is present at t equal to t naught. Therefore, the function f of t gets evaluated at the location of the impulse. In a strainer, where does the particles pass through? Where holes are there. Here, where is the hole? The hole is created by the function delta of t minus t naught. How to get the location of delta of t minus t naught? The quantity inside the brackets of impulse function, namely t minus t naught, equate it to 0. T minus t naught, if you equate it to 0, you get t is equal to t naught. Now you see here, how to get the location of this impulse? What is the quantity inside the brackets of the impulse function? It is t. Equate that to 0. You get what? T equal to 0. Therefore, the impulse function is located at t equal to 0. By the same logic, delta of t minus t naught is located at t equal to t naught. F of t gets evaluated where the impulse is present. This property is called shifting property and is very useful for evaluating the integrals wherein impulse functions are present inside the integral. Now, how to find Laplace transform of this impulse function? Let me make it very clear to you. Where do you come across this impulse function in practice? Let us say you are going in a two-wheeler. Suddenly the two-wheeler enters a pothole. You get a sudden shock. The shock is sudden and that is represented by an impulse function. Correct? Any sudden shock will be represented by an impulse function. Let us now proceed to find what is Laplace transform. What is Laplace transform of this impulse function? See, we know that Laplace transform of f of t by definition is integration 0 to infinity f of t into e to the power minus st dt. Hence, Laplace transform of impulse function delta of t is equal to integration from 0 to infinity delta of t into e to the power minus st dt. How to evaluate this integral? To evaluate this integral, use shifting property. Using shifting property, we get Laplace transform of delta of t is equal to, here the function f of t is e power minus st. Right, e to the power minus st will get evaluated where the impulse is located. The impulse is located at t is equal to 0. So e to the power minus 0 is equal to 1. Therefore, Laplace transform of an impulse function is 1. Similarly, please see, Laplace transform of delta of t minus t naught is equal to what? Integration from 0 to infinity delta of t minus t naught into e to the power minus st dt. Here, where the impulse is located, at t equal to t naught. How did you get it? What is the quantity inside the brackets of the impulse function? It is t minus t naught. Equate t minus t naught to 0. That gives you t is equal to t naught. So the function e to the power minus st will get evaluated where the impulse is located. Mathematically, it means e to the power minus st gets evaluated at t is equal to t naught. That means you get e to the power minus st to t naught. In this expression, if you put t naught equal to 0, you get this expression. So this is how Laplace transform of an impulse function is formed. Next, we will go to the second function. The second function is known as step function. To be more precise, it is called unit step function. Unit step function denoted by u of t. How do you define this function? U of t, by definition, if you put a triangle and equal to it, means by definition is 1 for t greater than 0, 0 for t less than 0. U of t is not defined. U of t is not defined at t is equal to 0. Mathematically, you can sketch it in this manner. X-axis represents time, y-axis represents u of t. U of t is 1 for t greater than 0, u of t is 0 for t less than 0. That means the function, if somebody puts a question at t is equal to 0, what is the value of u of t? You cannot tell, because at t equal to 0, the value is either 0 or 1. It is not known what is the value at t equal to 0. In other words, the function u of t is multi-valued are multi-valued at t equal to 0. Is not defined at t is equal to 0. Now I tell you how to find Laplace transform of this unit step function. Now before going to that, how to sketch? Let us now sketch u of t minus t naught. U of t minus t naught. How to sketch it? See, this is u of t, correct now? So u of t is given by this. So how do you get in u of t? Replace t by t minus t naught. U of t minus t naught is equal to 1 for t minus t naught greater than 0 or t greater than t naught. 0 for t minus t naught less than 0 or t less than t naught. You know the expression for u of t. In this expression, replace t by t minus t naught. So u of t minus t naught is 1 for t greater than t naught. U of t minus t naught is 0 for t less than t naught. Now let me sketch. X-axis represents time, y-axis represents t minus t naught. This is t naught. For t greater than t naught, what is the value? 1. For t less than t naught, what is the value? 0. The function looks like this. For t greater than t naught, its value is 1. For t less than t naught, its value is 0. In other words, u of t minus t naught is nothing but this function shifted to right by an amount equal to t naught. So u of t minus t naught means u of t shifted to right by an amount equal to t naught. Hence u of t minus t naught is nothing but u of t shifted to right, nothing but u of t shifted to right by an amount t equal to t naught. Similarly, u of t plus t naught represents u of t shifted to left by an amount t is equal to t naught. So u of t minus t naught represents u of t shifted to right by an amount equal to t naught. U of t plus t naught represents u of t shifted to left by an amount t equal to t naught. So if you want to sketch u of t plus t naught, this is how it looks like. Y-axis is u of t plus t naught. U of t plus t naught starts at t equal to t naught and goes to infinity with a value equal to 1. For t less than t naught, the value is 0. Next, let us proceed to find what is Laplace transform of u of t. Say, we know that Laplace transform of f of t by definition is integration 0 to infinity e to the power minus st f of t dt. Hence, Laplace transform of u of t is equal to integration 0 to infinity e to the power minus st u of t dt. Since u of t is equal to 1 for t greater than 0 and 0 for t less than 0, we get. So between 0 to infinity, what is the value of u of t? The value is 1. Hence we get Laplace transform of u of t is equal to integration from 0 to infinity e to the power minus st u of t is 1 dt. Integrate e to the power minus st, if you integrate you get e to the power minus st by minus s, limits from 0 to infinity. So this is minus 1 by s. If you put t equal to infinity, you get e power minus infinity. If you put t is equal to 0, you get e to the power 0. E to the power minus infinity is 0. E to the power 0 is equal to 1. Therefore, you get the result 1 by s. Therefore, Laplace transform of u of t is 1. Note, Laplace transform of u of t minus t naught. Apply time shift property. Forget about t naught. Forget about t naught. What is Laplace transform of u of t? Laplace transform of u of t is 1 by s. Since t is replaced by t minus t naught, the result should be multiplied by e to the power minus t naught into s. Please remember, Laplace transform of f of t minus t naught is equal to e to the power minus t naught into s into f of s. This property is used to find Laplace transform of u of t minus t naught. Okay. Next function that we are going to consider is called rank function. Is called ramp function. How do you define a ramp function? See, a ramp function is defined as follows. A ramp function is defined as follows. R of t is equal to t for t greater than or equal to 0. 0 for t less than 0. Let me sketch now. X axis is t, y axis is r of t. This is the equation of a straight line. What is the equation of a straight line? Equation of a straight line is y is equal to mx. What is y here? R of t. What is m? 1. What is x? T. This is for t greater than or equal to 0. For t greater than or equal to 0, r of t represents a straight line with slope is equal to 1. This is a line of slope equal to 1. This is the rad. For t less than 0, r of t is 0. This is how a ramp function looks like. Some people, instead of using two expressions for defining r of t, they use a single expression. They write r of t is equal to t into u of t. U of t, please note, u of t is either 1 or 0. U of t is 1. Let me sketch this and explain it to you. I'll write this as f1 of t into f2 of t. Please watch. Let me sketch first f1 of t. f1 of t is what? f1 of t is t. f1 of t is equal to t represents a straight line passing through the origin. The straight line extends from minus infinity to plus infinity. What is the slope of this line? Slope of this line is 1. Multiply f1 of t by f2 of t. What is f2 of t? f2 of t is u of t. u of t is 1 for positive time. u of t is 0 for negative time. Multiply these two functions. So you get r of t. What is r of t? r of t is equal to f1 of t into f2 of t. Please watch. This straight line, this part of the straight line is present for t less than 0, gets multiplied by 0. Therefore, this straight line becomes 0 in the expression for r of t. This straight line present, this part of the straight line present for positive time gets multiplied by 1. That means t gets multiplied by 1. So it remains t only. What I mean to say is r of t is equal to t into u of t means u of t is 1 for positive time, therefore t gets multiplied by 1 for positive time, gets multiplied by 0 for negative time. At t equal to 0, r of t is 0. That is because in this expression, if you put t equal to 0, irrespective of what is the value of u of t, r of t is 0. So instead of having these two expressions, a single expression r of t equal to t into u of t will do the job. Because, I repeat, u of t is either 1 or 0. It is 1 for positive time. Therefore, positive time t gets multiplied by 1. For negative time t gets multiplied by 0. At t equal to 0, since t itself is 0, 0 into any quantity is 0. Therefore, these two expressions can be replaced by this single expression. Next, let me teach you how to find Laplace transform of this ramp function. See, Laplace, let us now find Laplace transform of r of t. Laplace transform of r of t by definition is integration from 0 to infinity e to the power minus st into r of t dt. Since r of t is equal to t for t greater than equal to 0, 0 for t less than 0, we get Laplace transform of r of t equals integration from 0 to infinity e to the power minus st. What is r of t? R of t is t dt. Now we will do integration by parts. T into e to the power minus st dt. First function is t into integral of the second function, which is e to the power minus st by minus s. Put limits 0 to infinity minus integral of integrated part, which is e to the power minus st by minus s, into differential of the first function. Differential of t is 1 dt. So in the first part, if you put t equal to infinity, e to the power minus infinity is 0. In the second part, if you put t equal to 0, again this function becomes 0. That means both upper and lower limits will give you a value equal to 0 when this function is evaluated. Let me repeat once again. If you put t equal to infinity, this function becomes 0 because e power minus infinity is 0. When you put lower limit, this product is 0 because 0 into any number is 0. So this is 0 plus 1 by s integration from 0 to infinity e to the power minus st dt. Come on, integrate e to the power minus st. If you integrate, you get e to the power minus st by minus s square. 1 by s into minus 1 by s into minus 1 by s gives minus 1 by s square. Limits from 0 to infinity. E to the power minus infinity is 0, e to the power 0 is 1, so you get 1 by s. So Laplace transform of ramp function is 1 by s square. So you should remember, Laplace transform of an impulse function is 1. Laplace transform of a step function is 1 by s. Laplace transform of a unit ramp function is 1 by s square. Very, very important. Next, I teach you S models for circuit elements. S models for circuit elements. First I take resistor. Say resistor. Let me take all the resistance of a resistor. Right? Let a voltage V of t be impressed across this resistor that results in a current I of t through the resistor. So what is V of t? V of t is equal to I of t multiplied by R. All time domain functions are denoted by small letters. You should not write capital V for V of t. You must not write capital I for I of t. Taking taking Laplace transform on both sides. Taking Laplace transforms on both sides, we get V of s is equal to R into I of s. V of s is equal to R into I of s. So let me write an electrical circuit based on this equation. So R remains R only, but voltage across resistor is V of s, current to the resistor is I of s. So this is time domain model. This is time domain model. This is called frequency domain model or S domain model. Frequency domain or S domain model. Next I will take inductor. An inductor has got an inductance equal to L. Let a voltage V of t be impressed across this inductor. Let I of t be the current to the inductor. The initial current in the inductor is I of 0. I of 0 could be I of 0 plus or I of 0 minus. You have been taught by your teacher earlier that the current to the inductor cannot change suddenly. That means I of 0 plus is equal to I of 0 minus is equal to I of 0. In other words, I of 0 is initial current through the inductor. This is time domain model. What happens to S domain model? Let us see. What is the voltage across the inductor? The voltage across the inductor is V of t is equal to L into di of t by dt. What is frequency differentiation property? Laplace transform of df of t by dt is equal to s into f of s minus f of 0. What is this property? Time differentiation property. I have listed this property earlier. Apply this property to this equation with current with f of t replaced by what? I of t. Taking Laplace transforms on both sides. We get V of s is equal to L into S into I of s minus I of 0. So this implies V of s is equal to S into L into I of s minus I of 0. Let us write a circuit. Let us write a circuit. This is N into I of 0. Let us write a circuit based on the above equation. So L becomes, please see the board, L becomes SL, and we have got a voltage source given by L into I of 0. This is plus minus V of s. This current is I of s. If you apply KVL to this circuit, you get what? Minus, if you write KVL to this circuit, you get this equation. So this is called S domain model. This is called S domain model. So it is not a simple affair when inductor is involved. L becomes what? SL. And the current and the initial current I of 0 becomes a voltage source equal to what? L into I of 0. The voltage source will have minus polarity where the current I of s is entering. Where the current I of s is entering, you have to put the minus sign for the voltage source. This is about the inductor. Next I will go to capacitor. Third element is capacitor. Capacitor. Let me take a capacitor whose capacitance is C farads. The voltage impressed across the capacitor is V of t. This voltage results in a current I of t. The initial voltage across the capacitor is V of 0. Initial voltage across the capacitor is V of 0 plus minus. Now this is time domain model. This is time domain model. What is S domain model? We have to see now. The current through the capacitor. Always I use the word current through S element. Voltage across. Current through. The current through the capacitor. The current through the capacitor is given by I of t is equal to C into dV of t by dt. C into dV by dt. Taking Laplace transform on both sides. Taking Laplace transforms on both sides, we get I of s. Once you take Laplace transform, let me repeat once again, you have to use a capital letter for small I. I of t is time domain. All time domain functions are denoted by lowercase letters or small letters. All frequency domain functions or S domain functions are denoted by capital letters. I of s. Please use differentiation property. You get what? S into V of s minus V of 0. This implies I of s divided by C. I of s is equal to C into S into V of s minus C into V of 0. This implies C into S into V of s is equal to I of s plus C into V of 0. Divide throughout by Cs. So get what? V of s is equal to 1 by Cs into I of s plus V of 0 divided by S. Using this equation, let me write an electrical circuit. Electrical circuit looks like this. C becomes what? C becomes 1 by Cs. This initial voltage V of 0 becomes a voltage source. V of 0 divided by S. This is the circuit called as S domain model. This is called S domain model. Apply KVL to this circuit. Minus V of s plus 1 by Cs into I of s plus V of 0 divided by S. V of 0 divided by S gives you this equation. What is important here is C becomes 1 by Cs. This initial voltage V of 0 becomes a voltage source V of 0 divided by S. Here, please note that where the current I of s is entering, positive terminal is presented. In the case of an inductor, negative terminal is shown. Okay. These are the S domain models for different circuit elements. Now we'll do a simple problem in order to fortify the concepts explained.